Hello students, welcome to my first science video for PSC students, and in today's video we want to cover three objectives. One, we want you to get a good understanding of magnetism or magnet. Two, convection, conduction and radiation. And three, to get a good understanding of Newton's three laws of motion. Remember, you can subscribe for quick access of all the videos that will be posted. With no further delay, let's go straight into magnetism. So what is magnetism? Magnetism is an invisible force seen when all electrons spin in the same direction. When you bring two magnets together, they exert a push or pull called a magnetic force. So it could either attract each other or repel, which means that they will fight against each other and they will never attract. This force results from spinning electric charges of electrons in the magnet. The force can either push magnets apart or pull them together. Magnetic force is one of only three forces in nature that can act at a distance. Again, magnets have two poles, north and south pole. Then like poles repel, unlike poles attract, and magnets create a magnetic field around them. So it doesn't matter the shape or the size of a magnet. If you have two magnets facing each other and the poles are south pole and south pole, which are the same pole, or north pole and north pole, that magnet will repel, which means that the magnet will never attract or stick to each other. But if you get two magnets and you face them north pole and south pole, or south pole and north pole, that magnet will surely attract or stick to each other. Okay, so let's go straight into convection, conduction and radiation. What is convection? Convection is a transfer of heat through a fluid, which is liquid or gas, caused by molecular motion. Then conduction is a transfer of heat or electric current from one substance to another by direct contact. And radiation is the energy that is radiated or transmitted in a form of rays or particles. So convection, let's explain each one in a little more explanatory form. Convection is like, for instance, when you're boiling your water, you can see the bubbles in your water because of the heat. That's the convection. Conduction is if you put a metal spoon in your pot, that heat automatically passes through the spoon, so you touch the spoon, and because the spoon is metal, you will feel the heat in that spoon. Your spoon will automatically get hot. Then radiation is you will just get your hand, put it over the pot, and you will automatically feel that heat. So you don't have to touch the pot or the fire in order for you to feel the heat. That heat is automatically radiated, and as you put your hand over the pot, you can automatically feel the radiated heat. On a constant basis, we get the radiated heat that comes directly from the sun. And again, another explanation of convection, conduction, radiation. Convection, energy is transferred by the movement of matter. And for instance, remember again, let's use that example. You have your pot of soup on the stove. The soup is heated by convection. As the hot soup rises, the cold soup moves down. Then conduction, energy is transferred by direct contact. Heat energy from the stove is transferred to the pan by conduction. And radiation, energy is transferred by electromagnetic radiation through space or air. Then also for radiation, the heat energy from the stove is transferred through the air, warming the space in the kitchen. So whenever your soup is on the pot, you don't need to put your hand in the soup. You go close by and you will feel that radiated heat. And remember, we get that radiation or radiated heat daily from the sun. And the final thing that we want to cover is Newton's laws of motion. And there are three of them. The first one is an object continue in its state of rest or motion unless an external force is applied to it. So that's the first law, and that is known as inertia. The second law of motion is the greater the mass of an object, the greater the amount of force it needed to accelerate it, which means to speed it up. And the third law of motion says, for every action, there is an equal and opposite reaction. And let's go into each of these three laws into more details. And the law of inertia is the first law, and inertia states an object at rest stays at rest, or an object in motion stays in motion in the same direction at the same speed unless acted upon by an unbalanced force. And this is also called the law of inertia. A good example, if I get my cup and I place my cup down, that cup tends to stay there. Reason that cup will move is if a force will come and move that cup. Or for instance, if I throw something on the ground, inertia states that whatever I throw on the ground tend to always want to go on and on and on or move. But there will be some force that will bring that item or that material to a stop. So a good way to understand inertia is to use it in a term of laziness, means that if you set something down, whatever you set down will tend to stay right there. But it will take a force to move it. And whenever that force moves it, only thing that can stop whatever is moving is another force. So again, remember Newton's first law is called inertia. Inertia, things always want to stay where they are, or if you have them moving, they want to tend to keep on moving and moving unless they are stopped by a force. Newton's second law of motion states, to simply put it, the more force, the more acceleration. So the more force you put on something, the more it will speed up or it will move quicker. Because Newton's second law states, if you apply more force to an object, it accelerates a higher rate. And accelerate just simply means that whatever you're moving will move with a quicker speed. A good example of acceleration, if you're pushing something and you're pushing it with a little force, it will move, but it will move slowly. But the more force you put on whatever you're pushing, like a wheelbarrow for instance, that wheelbarrow will accelerate or move faster. So remember Newton's second law, the more speed, the faster something will move, to simply put it. And again, Newton's second law, if you apply more force to an object, it accelerates at a higher rate. The force equals the mass and the acceleration. So the mass is the weight, the heavier something, you'll have to push with more force. And the more force you push, whatever you're pushing will accelerate or increase speed. Again, we want to continue with Newton's third law of motion. It says for every action, there's an equal and opposite reaction. And a good way to put this is a ball. When you throw a ball up into the sky, the action or the air rushes the ball down and the ball touches the ground, which is the action. And after that ball touches the ground, the reaction is the ball bounces and goes up. So that is a good example of action, reaction, and some other examples of action and reaction. The action, it says exhaust gases are pushed out of a rocket, and the reaction, the rocket pushed forward by the gas. Then, the next example, it says a vase of flowers presses down on a table. That's the action. The reaction, the table pushes upward on the vase. Another example, a softball is hit by a bat. The reaction, the bat slows down as the ball pushes back. And one final example of action and reaction. For the action, an orbiting satellite is attracted to the Earth. The reaction, the Earth is attracted to the satellite. So remember Newton's third law, for every action there is an equal and opposite reaction. Thanks so much for tuning in. Remember, you could subscribe for more videos. Look forward for many videos on the different topics and for part 2 of my science video.